Hello, everyone. Welcome. Today, I'd like to talk to you about Ethereum's intent machine, or intent machines for Ethereum, effectively, and why intent machines matter, what intent machines are, and why I think going forward, most abstractions will be at the level of intent machines rather than at the level of VMs, albeit they're building intent machines are common abstractions on top of VMs, such as many different rollups or many different EVM-based rollups. One sec. There we go. Okay, to start off, I'd like to quickly go through sort of what is a VM, what is an IAM, what are the differences, and why does it matter? So a VM is fundamentally what we know from existing infrastructure. So for example, the Ethereum virtual machine, that's a virtual machine, that's a VM. It has an instruction set, it's a program counter, it has different levels of memory that programs can address, and all the programs are run sequentially within this VM. So yeah, as I said, this is sort of, the EVM is a prototypical example of a virtual machine, albeit over the years there have been many advances, or there have been many different attempts to build kind of different VMs. For example, you have now the Solana virtual machine, you have the Nia virtual machine, right? You have many of these different virtual machines, but so especially within our ecosystem here, the predominant VM that's actually deployed in practice, given on Ethereum main chain as well as on most of the rollups, is really an EVM. So, okay, given that this is roughly what we know about, this is a VM, and this is what sort of the model that we currently have. Currently, everyone is directly programming against these virtual machines, right? Like when you write a smart contract, you directly deploy one of these programs to run on the Ethereum virtual machine. This has a bunch of sort of consequences that I'll talk to you about in a bit. But first, let's go into what is an intent machine, or what is an IAM. And an IAM really takes a batch of intents, computes possible valid state transitions, and then selects one of them as according to some criteria, to update the system state. This is important from the perspective that most users don't actually have transactions. When you live in a world where the only thing you do is simple transfers, then yes, you have a transaction because you're a fully fledged thing that you can immediately settle against the existing state. However, as soon as you want to do something more complex, for example, trade, you don't have a transaction anymore. You have an intent. You have a partial thing. I have A to B, but I don't have B to A. An intent is not something that I can execute on-chain as is. I need to gather together a bunch of intents, combine them potentially, and then sort of settle the net state changes on-chain, right? And really, 90% of all interactions on blockchains are intents. Intents are simple trading intents. For example, a limit order is just an intent, but even something as complex as a rollup, that's still an intent-based system, because when you think of a rollup as transition, someone has an intent to go from A to B within the rollup, someone else has B to C. What a rollup does, it collapses the compute into A to C. So a lot of the systems that we're currently building that require counterparty discovery, or that require interactions with other parties in the ecosystem, are actually intent-based systems. And so an intent machine is specifically, it's an abstraction designed to handle the fact that most users actually have intents and not transactions directly. And so the intent machine, actually, the other important thing to note here is many people will talk about intents, and they will say, well, aren't intents just limit orders? And really here the answer is, well, all limit orders are intents, but not all intents are limit orders. Intents are the generalized intents are generalized intents, really, and limit orders are very specific subset of intents. So one example I'd like to talk to you about today is the Anoma resource machine, which is really the first intent machine, first generalized intent machine. And I'd like to start off with saying there's a big difference between interfaces and intermediaries, and Anoma is an interface. It is not an intermediary. And I think there. So intermediaries are actors on a network that can extract rent, that add to your security model. They're generally a party that you send things to, that you interact with. And they may very well be decentralized, right? Like an intermediary is even a network. or a multi-sig. It's always like someone you interact with. And generally, we should avoid adding unnecessary intermediaries. You shouldn't just be an intermediary for the sake of being an intermediary, because in almost all cases, you're going to add latency as well as complexity, and in most cases, you're going to also add extra security constraints on the system. And I think that, yeah. So, for example, many bridges in the ecosystem are currently intermediaries. They are not interfaces. They are someone you interact with, someone who you now have to consider within your security models. As an example, many of the current bridges to sort of L2s end up being intermediaries because I have to fundamentally trust that they operate the bridge correctly and that they don't steal funds, for example. And they will charge fees and so on. This actually has a very good analogy in real life, which is banks are intermediaries, or that they are the traditional intermediaries. Technically, we should all be interacting directly with the financial system without having to go via banks. I mean, it's kind of weird that in order to send a transfer, you have to go via a bank because the bank just settles it somewhere else anyway. Why can't people directly go to the actual settlement system, right? On the other hand, we have interfaces, and interfaces are just protocols. They are sort of common definitions of how we encode data, how we send data around, but interfaces don't actually take a role in the security. I mean, like, if the interfaces are badly designed, they can be used insecurely, but an interface cannot get hacked in that sense. An interface, it's not an intermediary that can be attacked. An interface is just, it's an architectural definition, it's maybe an implementation that everyone is free to use. So they're simply really code. You can freely copy them, you can implement them anywhere, and they're usable by everyone. And sort of the prototypical example for interfaces is TCP/IP. Everyone can use TCP/IP. You do not have to go via the single Oracle server run in a basement in Virginia in order to use TCP/IP. If two of us in this room want to connect with each other, we can do so over TCP without asking any intermediary for permission to do so. Another good example here in the blockchain space is actually something like IBC, which is, again, just an interface. Yes, and so the Anoma protocol it's an interface. It's a sort of common abstraction for declarative intents, where you have a common abstraction using declarative intents over imperative ordering, compute, and storage. Right? Like, it abstracts away the semantics of whatever underlying virtual machine you want to use or whatever underlying security model you want to use. Yes, this is really important to me. There is no Anoma chain in that sense. There's no everyone must send all intents to this one thing. And so there's also an important technical reason for why this must always be the case, because as soon as you're an intermediary, you're a scaling bottleneck, right? Because somewhere we have to the intermediary has to expand some amount of compute in order to do work. As in, if Anoma was an intermediary, this would become the problem that, well, now you have to handle this kind of global scale thing, where what happens if 100 million people try to send you their intents? So in Anoma, there's no intermediary. You can just use the protocol as is without having to send it to a specific chain or a specific bridge. Yes, we should really think about this more. We should be using interfaces, not intermediaries. Every time you use an intermediary, your trust model gets worse, and not in the sense that, like, the intermediary will definitely screw up, but in the sense now you have to think of more things. It's not as easy as, like, oh, I use one thing, now I use like 15 different things, and I have to understand the combined security model of those. So, yes, Anoma is a universal intent machine for Ethereum. And what does this actually mean in practice? Builders can write dapps in terms of intents instead of transactions. And really, this is the first time, this is the first sort of generalized intents, where instead of writing a specific transaction that has to be included on chain to then get executed, users can rather write generalized intents that can do whatever those users actually want them to do, right? So, like, one example of an intent, again, is very, very simply, it's a limit order. A more complex intent is, for example, me and 5 friends want to participate in a Gitcoin DAO funding round. And so if we submit this as intents rather than as transactions on chain. So as a fun side note, this is also way more scalable because intents can be free. intents don't have to be actually executed on chain until they're settled. So I can, for example, issue an intent every half a second in order to keep updating a price point. Yes, what does this mean as well? It's just a universal standard for intents and application formats. That's it. It does not constrain at all what kind of different intents can be expressed. You should really think of intents as code. They're more declarative than just an imperative execute program. They actually, under the hood, define, so if you have the current state and then an intent is willing to accept the future state, and then there's some amount of code that can sort of verify whether this was adhered to, but in the end, they're very declarative. It's like, I'm currently at state A, I'd like to be at state B, and then someone else can figure out how to get me there. This is very different to the model of transactions where you define the compute that must take place. So you still, somewhere in the system, solvers still define the compute that must take place, but it's not within the intents. Like as a user, I don't have to worry about it. So as a user, I just say, these are my declarative state updates that I'd like to achieve, and someone else takes together, I don't know, 100 different intents, combines them, and then figures out what is the actual compute in order to satisfy these 100 intents. And the really important point is intents and dapps written with this universal abstraction can be ordered and solved sort of in Anoma, but actually settled on Ethereum or some rollup. Like to a large extent, this kind of abstraction generalizes shared sequencing and will help with liquidity, with the fragmentation of the ecosystem, where currently everyone runs these individual VMs and we don't have a good abstraction on top of all of them. With the intent machine, we actually starting to have an abstraction that can sit on top of Base, on top of Ethereum. And as a user or developer, I just have to think, I'd like to sort of do a specific thing. And as a user, I can then define which security model I'd like to execute this in, right? Like I write my intent is capable of being settled in either Ethereum or Base. And the nice thing is you also get composability here, which I'll talk about in a little bit. Oh, the really fun thing, or the really nice thing is, it means that applications can roam. So currently, I have an application to be on Base, I have an application to be on Ethereum, I have an application to be on I don't know, Arbitrum, right? And I find these applications are all different, and I have to fundamentally pick which ones I want to interact with. With the intent machine, I can rather my client, my phone can sort of roam across these different security models by just setting I'd like this to be secured by Arbitrum, and this, because it's a $100,000 transfer, I'd like this to be secured by Ethereum, and I'd like this to be settled on Ethereum. Yes, this is sort of the important takeaway. Intents and dapps written with Anoma can be ordered and solved and settled on Ethereum. Oh yeah, right. And this is sort of the thing I was speaking about, which is you can also settle them within the wider ecosystem, where, yeah, this is just going to help with a lot of the fragmentation that we're seeing at the moment. So what does this look like in practice? What kind of affordances does Anoma give you to build dapps? You get permissionless infrastructure. And here, permissionless get thrown around a lot. This specifically means there's no central actor, or there's no actor that you have to ask for permission or to use the system. Of course, there must be someone that's operating node infrastructure, but there's not sort of a specific whitelist you have to apply for in order to use this kind of system. You just get permissionless intent infrastructure here, that as long as there's some node operator that operates intent infrastructure on your favorite rollup of choice, you can use it there. You get intent level composability, and there's actually two parts to this. You get intent level composability as well as intent machine composability. And intent level composability very simply means that currently when you're interacting with something like CowSwap, for example, you have to your transaction is specific to that system, to the application. And it's very difficult to compose different interactions, even within the same securities model, like within Ethereum, at the intent level. With intents, you can have many intents, some that want to solve on CowSwap, some that want to participate in Gitcoin DAO, and they just compose with each other. And actually, before we go into this, you also get machine level composability, which means that as a user, you can treat one network. The network may be composed of many different security zones, but as a user, I can sort of treat it via the common abstraction and only have to think about this as a single intent machine with many different settlement zones. So instead of having to think about like, well, there are these 15 different things in the ecosystem that I'd like to settle on, I can rather think of it in terms of the intent machine and go, I just like to interact with the intent machine and I don't actually care what specific settlement systems happen underneath or what these specific settlement systems do. You also get information flow control. And really this is to say that currently we're living in this world of lots of shared global state, which is not the best case from sort of a privacy or transparent, user data protection perspective, right? Like Vitalik was talking about this earlier around privacy. And with privacy, or if we want to have more control over our data, it must necessarily mean that our data moves towards edge devices. So like instead of living on a global blockchain somewhere in the sky, your data starts living on your phone. And when you want to do something with the state or this data on your phone, you have to selectively reveal or prove that you own parts of this data, right? And this is sort of what intents give you, because intents move a lot of the compute out of the sort of middle of the network and rather towards edge devices, where like I can make statements over my local state on the edge of the network and then submit them. And as a result, you can do things like, for example, I want to issue an intent where half the users want to trade privately and the other half want to trade transparently. And so the one half that wants to trade privately just has to, instead of attaching a plain text signature, they attaches your knowledge proof. But this is like not an application level concern anymore. It's a user level concern of what users want to do on the edge devices when they interact with these systems. So this is really what we mean here by information flow control. And you get heterogeneous trust. You get the capability to, as a user developer, to decide what kind of trust model do I want to be in. And here, there's a big difference between the trust model of something like Base, which has very different trust guarantees than mainnet Ethereum, right? And so here, at the intent level, you just get to decide what kind of trust model that you care about. And maybe you're good with either, right? Like you can say, I'm fine on Base, Arbitrum, Optimism, Ethereum mainnet, whatever. Give me whatever is cheapest or fastest, right? But maybe for some things you actually care about the heterogeneous trust model, and the intents just make this very obvious, let's say it this way. So the last bit is, what kind of novel dapps can you actually build here with intents on Ethereum? There. So, public signal. This is sort of an inverse of Kickstarter, where instead of being supply-side driven, where people propose ideas and then others decide whether they like those ideas, it's demand-side driven, where all of us in this room can start issuing intents which aren't executed, right? So like intents are just binding commitments that may be settled in the future. So we could everyone here that likes the idea of there being a Starbucks in this room, we can start issuing intents that say, well, I'm willing to contribute $5 if there's a Starbucks in this room. And this only actually gets sort of settled if we get enough, and if then someone is willing to sort of issue the inverse intent, which is I'm willing to supply a Starbucks pop-up store here because you sort of like gave me $500 to do so. This is really public signal is about inverting how we want things to get done rather than being supply-side driven, being demand-side driven. And I think this can work for a bunch of things. For example, I'd like to see more research funding into nuclear power, right? Like I can issue this as an intent. If enough people sort of feel the same way, it creates a very clear public signal that there's demand for a thing, rather than having to hope that someone satisfies it by supplying more research here. You can also build something like scale-free money. And I think this is actually really the end game for cryptocurrencies, because to a large extent, we're allowing everyone and their grandmother to start issuing their own monies. Right? So scale-free money is about the idea that everyone here in this room can individually issue tokens that represent sort of their purchasing power. And we can start relying on each other, where I say, well, I am willing to be paid in like you 100 people here, but not sort of 1,000 people on the other side of the town. So you can use intents to build very scalable financial systems where instead of relying on single currencies, we can rely on many different currencies that actually then start representing the trust model that exists in society or in an economy. You also have multi-chat. This is kind of, and by the way, these are just nice ideas for hackathons, really. Like these are all intent-based applications that you can start thinking about how to build them. Multi-chat is the idea that you can have a Slack-like experience without central servers, where I issue intents that represent messages. They may be encrypted, they may not be encrypted, they may be broadcast all. We may have individual servers spin up, like solvers, that sort of like, or gossip nodes that kind of combine a bunch of us so you can have a easy chat room access. But in the end, it's a very free form of connecting. And here maybe actually the important point as well is, and I forgot this earlier, intents allow you to do things local. And this is, I think, a very important characteristic of intents. They allow you to do things as local as possible. Rather than having to go via a global server somewhere, we can decide, well, the three of us want to trade in this room. We should do so locally because A, this is way more private because we're only revealing the data to the three of us. And B, latency really matters. And nothing will ever be faster than like light speed over like a meter long distance, right? There's nothing on the latency front that a global system can do better. And really, to me, I view this as intent machines are designed to allow you to be as sovereign as possible. And then promise graph, this is sort of, it's actually a system we're using internally while building out. So we're dogfooding promise graphs that allow you to coordinate across organizational boundaries, or like where organizational boundaries are fluid. So like teams can be rearranged on the fly in order to sort of actually map the structure of the work that's being done or that needs to get done, rather than sort of some abstractly enforced structure. Yes, if you're interested, there is more ideas here of what kind of things are possible to be built with intents. Join into the conversation. All right. Okay, quick TLDR. VMs, virtual machines, and IAMs, intent machines, are not its and not versus. This is very important. One builds on top of the other. You cannot have an intent machine without an actual settlement virtual machine under the hood. This is very important to understand. This is just a new generation of architectures that we can sort of build on top of the existing infrastructure. This is not there to replace existing infrastructure. If we do not have settlement layers, intent machines are very nice ideas that we can't settle anywhere. You want to be careful that we focus on interfaces and not intermediaries. Please don't go running into the next thing that promises you really cheap fees or like fast latency or low latency. You can do a lot there if you just build a single server. And this is really what a lot of the current systems end up being, because no one has a good abstraction for how to build for a generalized interface for how users interact with these systems. What does a universal intent machine mean for Ethereum? It means the capability to build intent-centric dapps. It provides a standard for intents and provides the capability to settle on Ethereum. Why use Anoma as sort of the first generalized intent machine? Well, no one really has proposed a completely generalized intent machine before, and this is fully spec'd out. And besides that, you also have permissionless infrastructure, intent-level composability, intent machine-level composability, and information flow control, as well as heterogeneous trust. And then we spoke about some novel dapps on Ethereum. If you like intents and like to explore the idea of intents further and what they can bring to this ecosystem and how intents can bridge a lot of the gaps that currently exist at the architectural infrastructure level, go to ETH Research. Christopher wrote a great blog post that sort of gives a very comprehensive overview of how intent machines will work on Ethereum. It is not a short read, take like an hour. It's pretty dense. It also links back to a bunch of the underlying research. If you're very curious, there's a bunch of research papers that sort of informed a lot of these choices. So I think that's it. Thank you very much, and that's it.